Students, let's move on to the next module of this chapter, and this module we learn something different, and this time we learn the introduction of something called as Sn. So far we have been doing sums based on An, the nth term or the general term of an AP, right? Now let's see what exactly is Sn. Sn is nothing but the sum of the first n terms. Here n represents the number of terms. The number of terms whose sum is to be found out. So S meaning sum, Sn is the sum of n number of terms whose sum is to be found out in a given AP. Is this thing clear? Now let's understand a few things about Sn. Now see, there is an AP given to you all. The AP is 3, 5, 7, 9. If I ask you all, what is the sum of the first term? The sum of the first term will be first term itself, that is 3, right? The sum of the first term is the first term itself, 3. So S1 is basically equal to A1, the first term. What is S2? S2 is the sum of the first two terms. So S represents sum to first two terms. So sum of first two terms is S2. In this particular example, it is 3 plus 5, which is equal to 8. S3 is sum of first three terms. In this particular example, 3 plus 5 plus 7, that's 15. S4 is the sum of first four terms. In this example, 3 plus 5 plus 7 plus 9, which is equal to 24. Now, if in an exam, you are given a sum like this, 3, 5, 7, 9, you can easily find out S1, S2, S3, S4 because you just need to add the first term or the first two terms or the first three terms or the first four terms. But if in the exam the question is find S37, the sum of first 37 terms, how do you do it? It is practically impossible for you to do it manually, adding all the 37 terms after finding all the 37 sums. It will be a very, very lengthy process. So to find the sum of any number of terms, we need to learn the formula of Sn. So to get the sum of the first 37 terms or 25 terms or whatever, there is a general formula, and this formula is basically Sn is equal to n upon 2 into 2a plus n minus 1 into d, where Sn represents the general sum, the sum of first n number of terms, where n represents the number of terms. A is the first term of the AP, d is the common difference. From where this formula is derived, the derivation is not there, you just in your syllabus basically, so you just need to remember this formula. Sn is equal to n upon 2 into 2a plus n minus 1 into d. Now let us simplify this formula. How do we do it? That 2a inside the bracket 2a, can we write it as a plus a, because a plus a is nothing but 2a. So let's do it. What do we get? We get n upon 2, instead of 2a we write it as a plus n minus 1 into d. Clear? Now see what we are getting. A plus n minus 1 into d. A plus n minus 1 into d reminds you of what? It reminds you of the formula of an, right? An is a plus n minus 1 into d. So replace it by an, you get the second formula of Sn, that is n upon 2 into a plus an, where here an is nothing but the nth term or the last term. You remember in a finite AP, we always used to consider an as the last term and find the value of n. Hope you all remember those concepts, right? So there are two formulae of Sn. The first formula is n upon 2 into 2a plus n minus 1 into d. The second formula is Sn is equal to n upon 2 into a plus an. When to use which formula? It's absolutely your choice. Just a simple tip. Whenever in a sum d is given, the common difference is given, use the first formula. When in a sum an is given, the last term is given, use the second formula. So if d is given in a sum, use the first formula. When an is given in a sum, use the second formula. When both are given, use the formula of your choice. I think the second formula is simple. You can use the first formula as well when both D and AN are given. Simple. Now let's move on to the sums in the next module.